So what we're going to do in this lesson is we're going to add and subtract rational expressions. We're going to take it back to Algebra 2. We're going to simplify rational expressions involving radicals. Again, Algebra 2. And rationalize numerators and denominators of rational expressions. Again, Algebra 2. Maybe a little bit of all three of those things went into college algebra as well. However, you should feel comfortable knowing that you saw these concepts in 2 previous classes, which is a good thing. Of course, in this class it's going to get a little bit more complicated. It brings it up to a higher level. So this right here looks complicated. This just shows you how to add fractions. If I'm adding fractions, I need to get a common denominator. That's all that says, common denominator. When I'm subtracting fractions, I need to find a common denominator, and that's what the next equation says. Multiplying fractions, you multiply straight across. Dividing fractions, remember, you multiply by the reciprocal. So you invert and multiply is what they're saying. It's the same thing, change it to multiplication and take the reciprocal of your divisor. And then divide out like factors. So we've done that already. You factor your numerator, you factor your denominator, and you cancel out common factors. So let's get started with adding and subtracting rational expressions. So we've got x plus 1 over x. Well, I like to, when I'm adding fractions, make sure all of them show the fractions that exist. So we've got x over 1 plus 1 over x. A common denominator is going to be x. So the first fraction needs an x in the denominator. So I'm going to multiply by x over x so that I'm multiplying by a factor of 1, not changing the value, just changing what it looks like. So we've got x squared over x plus 1 over x. And now we can rewrite that all over x. You retain the denominator and you add the numerators. Voila. Okay, so you retain that denominator, you retain the common denominator, and then you add the numerators. When you're subtracting, you retain the denominator and you subtract the numerators. And we'll try that in this next one. So I've got 1 over x plus 1. When I have a binomial or a trinomial, I like to put it in parentheses, minus 2 over 2x minus 1. X plus 1 doesn't have any common factors. It's in its reduced form. 2x minus 1 is in its reduced form. So I'm ready to say, well, what does the first fraction need to get a common denominator? The first fraction needs a 2x minus 1. So I multiply the numerator and the denominator by the same value, so that I'm multiplying by a factor of 1. The second fraction needs an x plus 1. And now you can see that the two fractions have the same denominator. So they both have a 2x minus 1 and a factor of x plus 1. So we're going to take, I'm going to use my highlighter, we're going to take 2x minus 1 times 1, and that's going to go right here. And then I'm going to subtract the result of 2 times x plus 1. Now, when I multiply 2 times x plus 1, it's going to end up being more than one term, so I'm going to use parentheses right there. So I've got 2x minus 1 minus 2x plus 2, 2 times x, 2 times 1, and then I'm going to distribute the negative. Some of you are probably thinking, why didn't you just distribute the negative right away? Usually I do. Usually I do. So I'll go back and show you that. I've got negative 3 over 2x minus 1 over x plus 1. And that's our final answer because nothing reduces. So I'm going to show you in red what I normally do. What I normally do is I normally circle this. That negative goes with the 2, and then I distribute the negative 2, which would give me negative 2x minus 2, which is exactly what I got right here.